Okay, this is my presentation on numerical analysis, and this is part 1 of 2, and this is on linear motion. So, what is the numerical model? Numerical model is basically where you use numerical factors to assess on supporting performance. There are three main reasons why people use this. So the first is to reduce risk of injury, second is to improve sporting performance, and third is to assess how effective current performance is. An example of this would be the test we did. So we assessed someone's rebounding in a basketball team, so we assessed who would be best to fill the power forward role by assessing their rebounding. So there are three different aspects to the numerical model. Firstly is linear motion. So there is also angular motion and projectile motion. We're going to focus on linear motion in this presentation. So linear motion, this is where motions are in either a straight line or they can be in a curved line. This uses factors like distance, displacement, speed, velocity and acceleration, and they use them to then assess the sporting performance. So if it was a runner, you'd look at like speed and distance and then work out if they're running effectively or not. So angular motion, this is where you sort of look at angles in the joints in the body while performing. So you'd film someone, maybe an example of this would be football when you kick a ball, so the leg bend at the knee, you film that and then assess whether it's in the right performance, the right technique, and if their kicking motion could cause injury to them. Projectile motion is basically where an object has been projected into the air, as it says in the name, projectile. And this basically just looks at the height and distance of the object that's achieved. Then looking at the height or distance, they'll assess whether the object's being projected in an effective position. So if it was long jump, high jump, they'd look at how high they jump and distance and whether they're doing this effectively and if they are achieving their maximum height. Okay, so scalars and vectors. So a scalar is a value that has a magnitude. So an example of this related to basketball would be how fast someone jumps when doing reaching for a rebound. Vectors are values that have a magnitude and a direction. So the example for basketball would be jumping up for a rebound, and then the vector would be how fast you travel up and how fast you travel down. And then it would also, the second part of the vector would be how far you travel. So distance is basically here, and it's the sum of how far you travel. Speed is how fast you do travel. Acceleration is the increase in speed. So these are all scalars. So this is because they only have one magnitude. So here we have vectors. So displacement is the distance between A and B. So it's how far you travel. So the two vectors in that are A, and then the second is B, where you start and where you finish. Velocity. So here, this is how fast the body moves and in what resultant direction. You can work this out by an equation, which would be velocity equals displacement divided by time. So displacement is 1 and the other is time, so that's two vectors. Acceleration is the acceleration direction, even is how fast the change of speed or velocity is and what direction it's in. So obviously speed and then velocity are the vectors in that. These are all vectors as they have a magnitude and a direction. So Newton's laws. So Newton's first law is an inertia. This says that basically if an object is pushed forwards in a motion, then unless there is a force reacting on that, then the object that's moving will never stop. So if you think of an ice hockey puck, when there's little resistance and you hit it, it will go on forever. It would never stop if there's no resistance. But then if it hits something like the wall, or there's lots of wind, then that's a resultant force that's acting on it to change the motion. So the second law, this states that acceleration is proportional to the force causing the acceleration. So an example of this is basically when a sprinter accelerates in a 100-meter sprint. The sprinter accelerates in proportion to the amount of force that the muscles can produce. So it doesn't accelerate really fast but not push, like it has to move at a rate that's pushing it forwards. So the third law, action and reaction. So this says that for every action there is an equal and opposite reaction. So an example of this would be jumping up for a header in football. So when you jump, you exert a force onto the floor to push you up on the ground, and then the ground will equal your force, so then you can propel yourself in the air. Okay. Center of mass and stability. So center of mass is basically a point in the body. It can also be outside the body depending on the body's position, where the body is sort of balanced in all directions. So having a low center of mass, this will make you very stable. Having a different body position will affect the center of mass. So an example of this is when jumping up for a layup. The center of mass will be outside your body, just above your knee, just to keep you balanced in the air so you don't then like fall backwards or fall forwards. The opposite to this would be when you're crouched to perform a rugby tackle. Center of mass is going to be around the hip area to keep the person stable while tackling, so then they don't fall forwards again or fall backwards. And so when they actually do tackle the person, they're not just thrown backwards or thrown to the side. They're stable and can hold their body. So stability. Stability is basically where the body is in a position which it will be hard to then like knock over or fall over or be overturned. Then you can also create stable stability. This can consist of lowering the center of mass, which will be like crouching down, like bending your knees a little bit. Making sure the line of gravity is within the base of support. So this is usually within your legs. So if you're standing up, then the base of support is in your legs. I guess if you're standing on your hands, then it's between your hands. So the final step would be to make more points of contact. If you think of a tripod, it's really like sturdy, like you can't really knock a tripod over that easily. If like it's not just going to fall over on its own, you need to have a force amount push to it quite hard. So if you were then on like, if you put your hand down, that would stabilize yourself even more. If you put two hands, that would also stabilize yourself. And then rearranging your hands in different positions would also stabilize you even more. Okay, so instability is created when opposites to these occur, so a higher center of mass, or a line of gravity outside the base of support, or a really narrow base of support. And also if you have less points of contact, then like if you're standing on one hand, then you'd be less stable. So the method. Okay. So rebounding. Last year, 3,353 offensive and defensive rebounds were made. This is the combination of the top 3 offensive and defensive rebounders. DeAndre Jordan made 15 rebounds each game on average. As you can see, rebounding is a very important aspect to basketball. This is because whenever a shot is missed, then it needs to be rebounded to either win or prevent the other team winning the ball. This is why we are doing this test basically on our 2 candidates for the power forward role, just to give us information on who's the better rebound and then deserves to be in the starting lineup playing the power forward role. So now I'm going to go into detail on our method. So we did 3 jumps on force plates which record the force you're applying to the ground when jumping up and the height you jump, and it gives you loads of information. So for the jumps we did 3 different jumps. We did a counter movement jump where they can use their arms to swing to propel them. We did a 90-degree jump, so the 90-degree angle at the knee bend, and we also did a 45-degree angle at the knee. So we prepared our client for the 3 jumps. They firstly had to fill in a consent form to prevent like them being able to sue us if anything was to go wrong, and also so we've got cover. We also had a warm-up on a spin bike. This is to prevent injury. We then had to weigh the participant for the force plate to get accurate results. We then started by measuring the angle at the knee, so they would then jumping with the correct angle and not like cheating, just to make it a fair test. We also made sure the participant had the white stickers on their upper and lower legs to make a virtual image of the leg whilst jumping. We also had to prepare the equipment here. This consisted of recording the participant's weight in newtons on the force plates. We then clicked start on the computer so the force plate recorded the force of the jump. We counted down from 3 to 1 and pressed start while on 2, so therefore the results show how the participant went from standing, then jumped back to standing. We also recorded the jump on a camera. This was done on an iPad camera. We started recording when counting on 2 as well from the camera, so we don't miss the jump due to the iPad's slower shutter speed than really high shutter speed cameras. We also had Vicon cameras around the room. This will record the jump from all angles and then prepare a digital version of the participants. So, camera setup. We used an iPad to film along with the Vicon software at the university. The Vicon camera is made up of lots of infrared lights that pick up movement. So the white stickers on the participant's jumper will then build a visual image of the person. The setup for the Vicon cameras is done by the professional, so we didn't do this as we're not professionals with the equipment and it's quite high tech. So we also did use an iPad, however the iPad was set up without a case. It was used by one of our students and filmed all the jumps, but it did not have a stand for the camera. It was just propped up with the case, as you can see here. So it does do the job, but it's not really sturdy, so that is a slight flaw. So it could easily fall over, missing one of the jumps, which could corrupt the data potentially. The footage may also be a bit shaky from not having a stand. Cameras that we used also needed to have a good frame rate, so it's clearly capturing the movements of the jump at the joints where they flex. We also need the camera placed in a position where it covers the full body of the participant when jumping. The camera needs a high shutter speed, as a low shutter speed will appear blurry. A high shutter speed will appear clear, however it can get too high and then become a bit bright. There are 3 planes of motions. These are sagittal plate, frontal plate, and transverse plate. The planes are the body being cut in different places, and it requires the different places and movements to film different activities. So sagittal plate, this is where the body is cut in half along the middle between the 2 eyes. The frontal plate is where the body is cut in half, the opposite to sagittal, so with your chest on one side and your back on the other, so down the middle. The transverse axis is where the hips are cut in half, separating the upper body with the legs. So there are also axes of movement. These also create movements. There is the transverse axis, vertical axis, and sagittal axis. The axes are like a thin line through the body, where flexion can take place. So it'd be like if you put a stick through someone. The transverse axis is through the side of the body, so about the hips probably. The sagittal is through the front of the body, around the belly button, and the vertical axis goes in the middle of the body from top to bottom, so it'd be go from the top of your head right down through your body. We will need the camera to be on the side onto the performer, capturing the sagittal plane of movement, with movement coming from the transverse axis of the participant. This is the data we collected from doing our test, of which we will then go into more detail, making graphs and charts in 6.4, where we'll be comparing these and finding out who is the better option for the power forward role. Thank you.